Today we are going to solve this improper integral. So the first step we want to do is we want to replace infinity with some letter. Let's say b. So we'll have to take the limit. Oh gosh, this is a terrible limit. So let's say let b approaches infinity. So we can swap out infinity with b. And then we can do a pretty nice u substitution here, because if we let ln of x be u, du is already here, is 1 over x. But one thing that to be careful is this now will be u to the negative 3 du. The reason why this exponent will be negative is the ln, this stuff, right? ln of x is not being multiplied to the top. It's at the bottom with this x. So that's an indication that your exponents will be negative. Okay, so we can just do the reverse power rule. This will be the limit as b approaches infinity of negative u to the negative 2 over 2. And then, yes, if we were to simplify this, this will be evaluated at b and e. So we want to simplify that a little bit. This will be what? It's 1 over u squared over 2. So 2 goes here. That's negative. Yes, this looks correct. Then, of course, evaluate it at e and b. So let's continue. This is basically what? If b is approaching infinity, this is going to be 0, because if you have a really small number divided by a really big number, that would be 0. So 0 minus negative 1 over 2 e squared. Oh wait. Oh yeah. I skipped one really important steps. So just before we do all that, we have to remember to plug back the ln of x, because we let ln of x be u. We can't just like evaluate things at u. We have to plug things back. So 2. Was that a 2? Yeah. So ln of x to the second power. Yep, that looks a lot more. Yeah, that makes more sense. So, well, same thing, right? If you plug in b into that, you'll have a minus 1 over 2. Well, ln of infinity is already infinity. You have what? Infinity squared, that'll give you 0. So we'll have the same thing, right? So it's going to be 0 minus negative 1 over 2 ln of e squared. Ln of e is just 1 because base is e, and then that squared is also 1. So this is going to be 0 plus 1 over 2. So the answer is just 1 over 2. Yep. And that's how you solve it, ladies and gentlemen. When you have improper integrals, the first step you want to do is you want to replace your infinity with some other letters, and then have that letters approach infinity by using our limit definition. And then you just solve this integral like you would as usual. Then you want to solve it like a limit, right? And then you want to be careful with when stuff are going to infinity and when stuff are going to 0. And then the rest should be relatively straightforward.